That's okay. Right. I'm now going to show you the 4 most confusing error messages in Python. And the 4th most confusing error message in Python is to do with local variables and variable scopes. And it goes particularly well with closures. We've just done closures and decorators. And before we move on to iterators and generators, let's have a look at this. So x equals 3, look at this code. When I call function, who can predict what will happen? Anyone want to volunteer? Based on what we've learned about variables and variable scoping so far. Well, it's tempting to think that when we call function, because we haven't defined or created the local variable x yet, that this x is going to refer to the global variable. So we'll print 3, then we'll set x to 1.
I would say that it will throw an exception.
Hey,
Yeah, I was going to say the same.
right, and you are correct. Because what happens is whether a variable is local, the scope of a variable is determined at bytecode compile time. So the assignment inside the function makes x a local variable. So at the point at which we call the function, it's an unbound local error. Now, normally, if you try to access a name that doesn't exist, Python gives you a name error. Name foobar baz is not defined. So that's the name, that's the terminology you're used to and you look for to recognize you've got an undefined variable. So for most people, the first time they encounter unbound local error, local variable x referenced before assignment, it's not necessarily entirely clear what that means. I reckon that's Python's 4th most confusing error message. And well done, those of you who guessed that it would raise an exception, because it does indeed. And if you get an unbound local error, it's because your code is using a local variable that has not yet been created. Okay, so there are 3 more error messages that are confusing than that, none of which you're that likely to see in practice, and all 3 of which have to do with multiple inheritance, and one of which has to do with multiple inheritance with metaclasses, and they serve as a salutary reminder as to why you should not use either metaclasses or multiple inheritance. Here we go. Type error. Multiple bases have instance layout conflict. There's some jargon for you. Multiple bases have instant layout conflict. The only reason you would see this is because you're trying to inherit from 2 different things written in C, probably or possibly built-in types, and they have a different instance layout. So at its most fundamental, when we're working with CPython, an object is a C struct, and there's a base pi object struct. Most objects have, and it has a slot for the reference count, for the dunder class, the type of the object, and so on, perhaps potentially for an instance dictionary. And the different types, the list, the float, they have different layouts. So if we inherit from multiple of these types that have a different layout at the C level, when we ask for an instance of this, Python is going to say, I do not know what you want, which is a reasonable thing to say. And so hence at creation, we get this type error. Multiple bases have instance layout conflict, and it's immediately obvious what that means. That's Python's 3rd most confusing error message. The 2nd most confusing error message is one you are very unlikely to ever see in practice unless you try to demonstrate it like I will. So we have 2 parents, 2 classes here, a child and a parent. And we possibly, by some more convoluted inheritance hierarchy potentially, are trying to create a class with multiple inheritance. And we attempt to create it like this. And if you remember from yesterday talking about multiple inheritance and Python cooperative multiple inheritance and the construction of the method resolution order, that Python follows 2 rules. The 2 are from the C3 linearization algorithm. And the first rule is that the order of declaration is honored, and this enables us to use multiple inheritance for mixing classes, which is the only valid use case for multiple inheritance in Python. And we put the mixing class first. And the second rule is that children must come before parents because children exist to specialize their parents. They must have an opportunity to override them. And following these two rules, parent must come before child, for that is the order in which they are declared, yet child must come before parent by virtue of that relationship. So we get this wonderful type error cannot create a consistent method resolution order for basis parent-child, which only makes sense if you understand an awful lot of things that nobody should bear the pain of having to understand. Right, that is Python's second most confusing error message. You are not likely to ever see that in practice. The most confusing error message, if you start tinkering with metaclasses, you might see it, and it is the reason to avoid metaclasses and instead use dunder init subclass, which is a wonderful, powerful technique, or use class decorators. So a metaclasses, classes are created at runtime. Everything in Python is an object. Every object has a type. It's the type. You can only perform operations appropriate for the types, and it's the type that's responsible for creating new instances. So if everything is an object, then a class is an object. What is the type of a class? It is a type. That's what they are. And it's the type that's responsible for making new instances. So classes are made by type. And I showed you the 3-argument form of type earlier for using type as a class factory. This makes type the default metaclass. And the genius of Python's metaclasses, they complete the Python type system, is that the type of a class is a class. So the thing that's responsible for creating classes, we can customize them by writing classes. So we can be hooked in at that level of the Python type system. And so why might we do it? Well, it's the type that's responsible for new instances. So customizing class creation is the typical use case for metaclasses. And that's better probably done by class decorators, which aren't inherited, or by dunder init, the class method dunder init subclass, which is specifically about inheritance. So we have some better mechanisms now in Python. However, there is a relationship between an instance and its type. And that applies between metaclass and the class. And one of the things is when the protocol methods are invoked by Python, for example, when you subscript into an object, so dunder get items is invoked, they're invoked directly on the type. So this is how a metaclass is used. We specify it like this. So thing is going to be the metaclass for foo. Thing is what's going to be used to create foo. I didn't override dunder new, which is what you do if you were customizing class creation. And it means foo is an instance of its metaclass. And if we subscript into the class as if it were, say, a dictionary, dunder get item on the metaclass is invoked. So I can customize the behavior of the class object through a metaclass, which is wonderfully tempting. And in fact, collections.abc, the ABC module, the abstract base class machinery uses a metaclass. The trouble is, if we do something like this, we'll create one custom metaclass for one situation, we'll create another custom metaclass for another situation. And then we have class first, which is using meta1. And we have class second, which has as its metaclass meta2. And then, God help us, we have abandoned all reason. And we create a third class that inherits from first and second. Metaclasses are inherited. A metaclass is inherited, and it's used to create the class. So which metaclass should Python use to create third, meta1 or meta2? And in the face of ambiguity, refuse the temptation to guess. An element of the Zen of Python, and like all of the Zen of Python, honored more in the breach than the observance. And here we get Python's most confusing error message, type error, metaclass conflict. The metaclass of a derived class must be a non-strict subclass, but the metaclasses of all of its bases obviously. How could anything else possibly be true? And there is a solution. And this, dear gods, is why we don't use metaclasses. Plus meta 3, inheriting from meta 1 and meta 2. And now, and so long as they're written with cooperative multiple inheritance using super appropriately and correctly, we can now make class third that inherits from first and second, and we give it a metaclass that is a non-strict a subclass of the metaclasses of all of its bases. And everything is hunky-dory, maybe. And there we go. That's Python's 4 most confusing error messages. The fourth most confusing, which is unbound local error. And it's where you use a local variable, reference a local variable before it's been assigned.